the law of diminishing marginal product and the law of variable proportion. If we plot the data in table 3.2 on graph paper, placing labor on the x-axis and output on the y-axis, we get the curve shown in the diagram below. Let us examine what is happening in the total product. Notice that total product increases as the labor input increases, but the rate at which it increases is not constant. An increase in the labor from 1 to 2 increased total product by 10 units. An increase in labor from 3 to 2 increased total product by 12. The rate at which total product increases, as explained, is shown by the MP. Notice that the MP marginal product first increases up to 3 unit of labor and then begin to fall. This tendency of the marginal product to increase to first increase and then fall is called law of variable proportion or the law of diminishing marginal product. Law of variable proportion say that the marginal product of the factor input initially rises with employment labor, increasing rises with employment labor, but after reaching a certain level of employment, it start failing. Why this happen? In order to understand this, we first define the concept of factor proportion. Factor proportion represent the ratio in which the two input are combined to produce output. As we noted, one factor fixed and keep increasing the other. The factor when the proportion change initially as we increase the amount of the variable input, the factor proportion become more and more suitable for the production and marginal product increases. But after a certain level of employment, the product process become too crowded with the variable input. Suppose table 3.2 decrease the output of a farmer who has 4 hectares of land and can choose how much the labor he want to use. If he uses one worker, he has too much land for the worker to cultivate alone. As he increases the number of worker, the amount of labor per unit land increases, and each worker adds proportionally more and more to the total output. Marginal product increases in this phase. When the fourth worker is hired, the land begin to crowded. Each worker has now has become insufficient land to work efficiently, so the output added by each additional worker is now proportionally less. The marginal product begin to fall. As we use this observation to describe the shape of the TP, the marginal product and the average product curve as below. Shape of the total product, marginal product and the average product. An increase in the amount of one input, keeping all the other input constant, result in increase in output. Table 3.2 show that how the total product changes as the amount of the labor increases. The total product curve in input output plane is positively slope curve. Figure 3.1 show the shape of the total curve of a typical firm. We measure the unit of labor along the horizontal axis and the output along the variable axis. With L unit of labor, the firm can at most produce Q1 unit of output. According to the law of variable proportion, the marginal product of an input initially rises, then after a certain level of employment, it starts falling. The marginal product curve then look like an inverse U-shaped as shown in figure 3.2. Let us now see what the average curve look like. For the first unit of the variable input, one can easily check the MP and we can easily check the MP and the AP are same. Now as we increase the amount of the input, the MP rises. Average product being average of the marginal product also rises, but rises less than MP. Thus, after a point of the MP start falling. However, as long as the value of the MP remain higher than the value of the AP continue to rise. The MP continue. Once the MP has fallen, when the MP has fallen sufficiently, its value become less than AP, and the AP also start falling. So the AP curve is also inverse U-shaped. So long as the AP increases, it must be the case MP is greater than AP. Otherwise, the AP cannot rise. Similarly, when the AP fall, MP is to be less than AP. It followed that the MP cut AP curve from above its maximum. Figure इतना show the shape of the AP and MP curve for a typical firm. The AP of firm factor 1 is maximum at L. To the left of the L, AP is rising and the MP is greater than AP. To the right of L, the AP is falling and MP is less than AP. Return to scale. The law of variable proportion rises because the factor proportion change as long as the one factor is held constant and the other is increased. What if both factor can change? Remember that this can happen only in the long run. One special case is the case in the long run occur when both factor are increased by the some proportion or the factor are scaled up. When the proportion increase in all input result in increase in output by the same proportion, the production function is said to display constant return to scale. When the proportional increase in all input result in increase in output by a larger proportion, the production function is said to display increasing return to scale. Decreasing return to scale hold when a proportional increase in all input result in increase in the output by a smaller proportion. For example, suppose in the production process all the input get double. As a result, if the output get double, the production function exhibit constant return to scale. If output is less than double, then the decreasing return to scale hold, and if it is more than double, then increase in return to scale. Return to scale. Consider if production function Q is function of f x1 and x2, where the firm produce Q amount of output using x amount of factor 1 and x2 amount of factor 2. Now suppose the firm decide to increase the employment level of both the factor t is greater than 1 times. Mathematically, we can show the production function exhibit constant return to scale if we have a function of t x1 t to x2 equal to t function x1 x2. If is the and that is the new output level f function of tx2 tx1 tx2 is exactly t times the previous output level f x1 x2. So the production function exhibit increasing return to scale f t x1 t x2 greater than t2 f x1 x2. It exhibit decreasing return to scale if f function of t x1 x2 comma t x2 bracket close less than t less than t t function of x1 x2. Cost. In order to produce output, the firm needs to employ input, but a given level of output typically can it is a decreasing return to scale. Cost. In order to produce output, and the firm need to employ input, but a given level of output typically can be produced in many ways. There can be more than one input combination with there can be more than one combination with which a firm can produce desired level of output. In table 3.1 we can see the 15 unit output can be produced by the three different input combination: L equal to 6, K equal to 3, L equal to 4 and K equal to 4, and L equal to 3, K into 6. The question in which the input combination with the form choose with the input prices given, it will choose that combination of input which is least expensive. So for every level of output, the firm chooses the least cost input combination. Thus, the cost function describes the least cost of producing each level of output, giving the price of the production and technology. COP production function. Consider production of Q equal to x1 A equal to x2 alpha, Q equal to x1 alpha, x2 beta, where the alpha and beta are constant. The firm produces a Q amount of output using x1 amount of factor 1 and x2 amount of factor 2. This is called the Cobb-Douglas production function. Suppose with x1 x dash 1 and x2 x dash 2, we have the q0 unit of output. Q0 equal to x dash 1 alpha, x2 dash beta. If we increase the both input t is greater than 1 times, we get the new output. Q1 equal to t x1 alpha equal to t x2 equal to beta equal to t a plus b x x1 alpha t x2 beta. When alpha plus beta equal to, we have q1 equal to tq0, that is the output increases t times. So the production function exhibit constant return to scale. Similarly, when alpha plus beta is greater than 1, the production function exhibit increasing return to. When alpha plus beta less than, the production function exhibit decreasing return to scale. Short and cost. We have previously discussed the short run and the long run. In the short run, some of the factor production cannot be varied, therefore remain fixed. The cost that a firm incurred to employ this fixed input is called the total fixed cost. Whatever the amount of the output the firm produces, this cost remain fixed for the firm. To produce any required level of output, the firm in the short run can adjust only the variable input. According to the cost that a firm incurred to employ this variable input is called the total variable cost. Adding the fixed cost and the variable cost, that we get the total cost of the firm. Total cost equal to TVC plus TFC. In order to increase the production of the output, the firm must employ more of the variable input. As a result, the total variable cost and the total cost will increase. As the output increase, the total variable cost and the total cost increase. Table 3.3, we have an example of the cost function of a typical firm. The first column shows different level of output. For all level of output, the total fixed cost is ₹20. Total variable cost increases as the output increases. With output 0, the TVC is 0. For 1 unit of output, TVC is ₹10. For 2 unit of output, TVC is ₹18, and so on. In the fourth column, we obtain the total cost as the sum of corresponding value in the second column, and the third column TVC, At 0 level of our TC's total cost is just fixed and hence equal to 20. For 1 unit of the total cost is ₹30, and for 2 unit of the total cost is 38. The short run average cost incurred by the firm is defined as the total cost per unit of output. We calculate it as short run average cost total cost by Q. In table 3.3, we get the short run average cost column by dividing the value of the fourth column by the corresponding value of the first column. At zero output, shortened average cost is undefined. For the first unit, shortened average cost is 30 rupees is 30, and for 2 unit the shortened average cost is 19, and so on. Similarly, the average variable cost is defined as the total variable cost per unit over the, if we value it as average variable cost equal to TVC by Q, on the average fixed cost is AFC equal to TFC by Q. Clearly, the shortened average cost equal to AVC plus AFC. In table 3.3, we get the AFC column by dividing the value of the second column by the corresponding value of the first column. Similarly, we get the AFC column by dividing the value of the third column by the corresponding value of the first column. At different level of output, the AFC and the AVC and the AFC and the VC are undefined. For the first unit of output, the AFC is 20 and AVC is 10. Adding this, we get shortened average cost equal to 30. The short-run average marginal cost is defined as the change in the total cost per unit change in output. Short-run marginal cost is change in total cost divided by change in output. Delta TC by delta Q, where the delta represent the change in value of change in the value of the variable. The last column in table 3 give a numerical example for the calculation of the shortened marginal cost. Value in this column are obtained by dividing the change in the total cost by the change in the output at each level of output. Thus at Q equal to 5, change in total cost equal to total cost at Q equal to 5 minus total cost at Q equal to 4 equal to 53 by 49 equal to 4. Change in quantity 1 equal to shortened marginal cost of 4 by 1 equal to 4. Just like the case of the marginal product, marginal cost is also undefined at zero level of output. It is important to note that in the in shorthand, fixed cost cannot be changed. When we change the level of output, whatever change occurs, that to total cost entirely due to the change in the total variable. So in the short run, marginal cost is the increase in TVC due to increase in the product extra unit of output. Final level of output, the sum of the marginal cost up to that level give us total variable cost at that level. One may wish to check this from the example represented through table 3.3. Average variable cost is at some level of output is therefore the average of all variable marginal cost up to that level. In table 3.3, we see that the output is 0. SMS is undefined for the first unit of output. SMC shortened marginal cost is 10. Second unit SMC is 8, and so on.